Welcome to section 10.2. Now we're going to look at a more specific counting principle for multiplication. These are called permutations and combinations. We're going to start off with permutations. A permutation is an ordered arrangement of R objects chosen from N objects. So in other words, you have all N objects to choose from. Let's say, for example, the alphabet. And you want to choose a certain number of the letters in the alphabet. We could say the vowels. And so how many possible arrangements are there of the 5 vowels that you take from the alphabet? Okay, or that's very specific. How about we just say any 5 letters? Now they're going to have more possibilities than just the vowels. So type 1 permutation, this is where our distinct objects can repeat, so repetition is allowed. So our number of ordered arrangements of R objects chosen from N objects in which the N objects are distinct and repetition is allowed is simply N to the R power. So an example, how many 3-letter airport abbreviations exist when the letters are allowed to repeat? So here, because we're allowed to have repetition, we'll make 3 blanks for our 3 letters. You're allowed 26 letters for the first letter, and if the second letter can repeat, you still have 26, and 26 for the third, so that's 26 to the 3rd power. In this case, the calculator says that's 17,576. Now, type 2 for permutations. Now you're going to notice it's without repetition. We still have an ordered arrangements, but again, repetition is not allowed. So this gives us what we call our permutation formula. You will see this in the calculator. We'll probably see this in the calculator, the N permutation R. It is a formula that uses our factorials that we talked about. So it's N factorial over subtract the N and R, and that's a factorial, that difference. And again, R has to be less than or equal to N. So now if I use that same example, how many 3-letter airport abbreviations exist, now the letters are not allowed to repeat. So again, 26 letters in the first option, but now let's say it's the P for Phoenix. You can't use P for the second spot, so now there's only 25 letters available. All right, so PH, can't use the P and H. So now that leaves 24 possibilities. Multiply that out, you get 15,600. Now, if we go by the formula here, 26 permutation 3, because there's 26 total letters, we want to choose 3 of them in our permutation. So 26 factorial over 26 minus 3, that's 23 factorial. And to simplify these factorials, as we've done before, you just start at 26, start counting backwards until you hit 23, which is matching the 23 factorial in the denominator. Don't go 23 down to 1. We'll just stop here, put a factorial, and we'll cancel those out. No reason to write 23 pairs of numbers and put 23 double slashes to cancel numbers. So there's your 26 times 25 times 24. Still 15,600. All right, and we can enter this into the calculator. So I'm going to bring my other calculator here, up and running, and I'm probably going to get that crazy blue screen again because I'm bringing different windows into play. Now, if you have the older calculator, all right, you have to type in the 26 first. Then you're going to go to Math, go over to PROB, Probability. Fastest way to get there is just hit the left arrow button twice so it wraps around to fraction and then to probability, and it's choice number 2. There's my NPR. Now with the newer calculator, whoops, I guess I hit the wrong button. Let me redo that. 26 math, boom, boom. Choice number 2, it puts the 26 in the little text box in a subscript position, just like you see here. And then you type in a 3, enter, and there's the 15,600. Now, the newer calculators, you don't have to hit the number first. You can go math, probability, number 2 for permutation. It leaves you 2 empty text boxes, and then you can just type them in. Just right arrow over to the next one. Still get the same answer. But if you have an older calculator and you hit the permutation, all right, and it shows up ANS, then the capital P, then it's trying to take your previous answer and use that for the N value. So you have to type in the 26 first. So you might want to play around with that with your calculator, okay? All right, so let's hope I can move this over and I'm going to get the blue screen. Here we go, click. All right. Next is our combination. Now what sets this apart is now it is a grouping. It is no longer an arrangement. It's a grouping. All right. You could say it's an arrangement where order does not matter. So permutation, let me go back to there. Order matters. The order in which things occur matter. So this is with permutations, you'll see a lot of things where they'll talk about first place, second place, third place. Or they're voting in a president, vice president, secretary of a club, treasurer of the club. The order in which they vote for people, it's a permutation. If they just want to have a club and have a committee of 4 people, no distinct titles, that's a grouping. Order doesn't matter. So the way we can write a combination, and again, there's no repetition in combinations either. Now you'll see C, N, R. You will also see this notation, which I'm not a fan of. And you will also see in our calculator N combination R, which you probably saw. It was right below the permutation. But in the formula is the permutation formula, n factorial over n minus r in parentheses factorial, with an extra r factorial being multiplied to the bottom. This right here is what removes all the repetitive arrangements, and we consider it as one group. So if I go back to my letter example, given the first 5 letters of the alphabet, how many 3-letter groups are there? All right, these are groups. So this is 5 combination 3. So 5 factorial over 5 minus 3, which will be 2, that will be a factorial, times the extra 3 factorial on the bottom. If it was an arrangement, it would be 5 factorial over 2 factorial. So start with the 5, start counting down until you hit the biggest factorial on the bottom, match them up so you can cancel them. The 2 will cancel with the 4, doesn't matter which order you cancel in, but this answer is a 10. And again, we can do this on the calculator. Older calculators, again, you got to type in the 5 first. Math, go over the probability, choice number 3 for the combination. Type in the 3, and there's your answer. All right. Next, how many 3-person committees of 3 people, kind of redundant, can be formed from 8 people? All right, so 8 is your n, so 8 factorial over 8 minus 3, which is going to be 5 factorial, times the extra r factorial, which removes the arrangements and considers it as one group. So 8, count down to 5. There it is. Line those up, we'll cancel those. Count down the 3 factorial, 1, 2, 3, or 3, 2, 1, whichever order you want to put it in is fine. But the 2 times 3 on the bottom is 6. We'll match the 6 on the top, so we'll cancel those. 5 factorials match up. 8 times 7, 56. So if you notice, this can go by pretty quick. And I hate to admit it, but very rarely do I do combinations or permutations in my calculator, because doing this is a lot quicker than typing it in because I got to go to different windows. All right, another technique for using combinations, how many groups of 4 people are possible, and you have 2 men and 2 women in this group. If there are 5 men and 6 women to choose from. So here I have to multiply 2 combinations together. I can't add the 5 and the 6 together and call it 11 and do 11 combination 4 because I put a restriction on the gender of my people, men or women, 2 and 2. So then I have to know how many total men and how many total women there are. And now we're going to go 5 combination 2, that's our men. And then 6 combination 2, that's our women. It doesn't matter which order you find these in, but you have to multiply the 2 numbers together. So 5 factorial over 5 minus 2, 3 factorial, times 2 factorial. 6 factorial over 6 minus 2, that's the 4 factorial, times 2 factorial. So we'll count it down, 5, 4, 3 factorial, count down the 2. Count down to 6, 6, 5, 4 factorial, match it with the 4 factorial, count down the 2, and we start canceling. 3 factorial can cancel, the 2 can cancel with the 4, making it a 2, so this is a 10. 4 factorial cancels, the 2 can cancel, and the 6 is 3. 3 times 5 is 15, so 10 times 15 is 150. Again, you can still type this in the calculator, just make sure you put the multiplication symbol between the 2 and the 6, and you can get your combination. So again, combination, important to understand. Order doesn't matter. All right, next we're going to talk about distinct permutations. This is a very, very difficult definition. I'm not even going to go there. It's a bunch of combinations together being multiplied. And it all simplifies down to this formula. So this is the formula I'm going to talk about and reference quite a bit. Now, you still start off with your n factorial on the top, but what happens on the bottom is you get all these r sub 1, r sub 2, r sub 3s, all the way up to r sub k. What's important to understand is that these are counting up the number of times one of your objects repeats. Okay? Now, all these numbers on the bottom, they all have to add up to be the n on the top. Now, we don't always have to list everything on the bottom. For example, how many distinct letter arrangements are there for the word Mississippi? Okay, well, there's a total of 11 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 4 I's, 4 S's, and 2 P's. No reason to count M as a repeating number. Now, the examples will do this in my math lab, but 1 factorial is 1, and multiplying by 1 doesn't change anything. So in my mind, I don't put that in there. I just put the repeating letters, how many there are, and make it a factorial. So 11 factorial over 4 factorial times 4 factorial times 2 factorial. So count down the 11. Ugh, this one might be a calculator problem. I'll show you how we can enter that. All the way down to 4 factorial. So that 4 factorial will cancel there. My other 4 factorial, I counted it down. My 2 factorial, I counted down. And now I start looking for cancellation possibilities, like the 3 times 2, that cancels the 6. The 4 and the 2, you could say go after the 8. And now you're left with 11 times 10 times 9 times 7 times 5, 34,650. If you have an older calculator, 11 factorial divided by, you have to put parentheses around the denominator. All right. If you go to the newer calculator, you can use that alpha command. Alpha y, get your fraction, 11 math jump over to probability for the factorial symbol, over. Now, if you recall when we talked about factorials before, we said it might be a good idea to memorize some of your factorials, like 4 factorial is 24, so you can just go 24 times 24 times the 2, get that number there. Okay? And the other thing I want to quickly show you so you understand what I'm talking about for a distinct permutation. Okay? So with the word Mississippi, Mississippi. Okay? Now, if we put on little subscript numbers, and I'm just going to look at the S's and make this a subscript 1, subscript 2, subscript 3, subscript 4. And if I rewrote my arrangement of letters, you can see that this is a different arrangement, but without the subscripts, I don't see that. So it's not what we would call distinguishable. So we're looking for another arrangement that's definitely something different. We could have M, whoops, that's not an M. That's a bunch of bumps. You could have MISSIPPISSI, a definite different arrangement. I can see visually the difference. I don't have to rely on subscripts. Okay?